digital numbers. The numbers is either 0 and 1. So 1 is a simple number, and the digital number is 0 and 1. So though the 0 and 1, 0 is for low voltage and 1 is for high voltage. But for 0 and 1, we also represent the different number values, like base 2. Base 2 is for binary number, base 8 for octal number, base 16 for hexadecimal number. We can change the number in any base. Okay. So the objective is that why the computer use the binary base 2 numbering system, and understand how to convert the base 2 number to base 10 or base 8 number, and understand that how to convert base 8 number to base 10 or base 2 number, and similarly for base 16 to base 10 2 or 8. This already covered in digital electronic system, so I just revise it, and after that I discuss the gate question, that what are the gate questions arise from the number system, and you also actively participate for the question answer session, because the aim is to crack gate. So why binary system? So computers are made of series of switch. So switch, for the switch on and off, 0 and 1 means high voltage and low voltage is required. So when it is high, then 1, low, then 0. So each state can be represented by a number. So the state, look at the, not the here the only the data, the state also in used as represented by a number, when 1 for on and 0 for off, 1 for on and 0 for off. So look at the system, that total 10011. Let's consider this is a system line. So this line, the 1 means this is on, and this line is off. Off means 0, off means 0, on means 1, and on, this line on is 1. So 10011. So here the least significant bit, LSB. LSB is the power of 2 to the power 0. If you go to the number 0, the 2 to the power 0 is the LSB, and 2 to the power, the highest 2 to the power is 2 to the power 4 is MSB. So LSB and MSB, if you consider the exponent value, so 10011 is basically the value of 2 weight. So 2 to the power 0, 2 to the power 1, here 2 to the power 2 and 2 to the power 3, the value is 0. So 2 to the power 4 is 16 plus 2 plus 1. So this is total 19. So from the binary to decimal conversion, it appears that the 19. So if I represent a 10011 in decimal, so it appears 19. But it's very difficult to say that the which switch is on and off. We directly say that this switch is on and this switch is off. So the number system includes the decimal, binary, octal and hexadecimal, and each system have 4 number base. Look at the 4 number base. The base 2, the symbol is B, binary for B, octal for O, that is base 8, and decimal for D, and hexadecimal for H. So if you consider the decimal number is started from 1, 2, 3, 4, 5, 6, 7, 8, 9, then the 0. So here the number from 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, these are the total 10 symbol used. Hi, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10, 8, 9, 0 is basically the symbol. The symbol, because we drawing it, no, one we drawing. So this symbols is, I clearly mentioned, this is a symbol, and this symbol is used as a number. Means this we give the name of that symbol is 1, the symbol 2, symbol 3, like that. So it is actually image, and we give the name as 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this image are now we called number, and this number is utilized to represent any digit, any numbers. So if it is 9, means the 9 amount is there. So computer utilize the binary system as a switch, okay, but we memorize in decimal conversions. So binary representation is a difficult task. Why difficult task? Because it larger in value. So for 64-bit computer, means that the number of digit is 64. So for easy calculation, we group the number in 3, that is the octal, 4 is decimal, and also the 4 numbers, the hexadecimal. The group of the decimal number and the octal number and hexadecimal number, we can group of 1. That if we use the 4 digit, then using the decimal symbol from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is actually not fulfilled, because hexadecimal, the digit count is 15. So the 15, and after 16 it started the repetition using the 0. So 0 is a symbol which is used for the repetition purpose. Means the number is 1 to 9. Number is 1 to 9. Then 9, 10. So how the 10 is formed? The 10 is formed by repetition. So the repetition 1 and its indication is 0, and it is placed into 10 position. So after 99, again the repetition, the 1. So and it represent 1. The first repetition is 0, that is 10, and second repetition is 0, and that is the 100. So in this way, in this combination, we can represent any digit in decimal. So in case of the hexadecimal is a pair of hexadecimal is a pair of 4 digit. So it start from 0 0 0 means 4 digit, and it end 1 1 1 1. So from 0 to 0 0 0 to 15, 0 0 0 to 15 means total 16. So that's why it is called the hexadecimal, means from a one unit of the hexadecimal digit, we able to count 0 to 15. So 0 0 0 is 0, 0 0 1 is 1. In this manner we count up to 15, and after that another 4 digit is used. Okay, so the decimal number system which I mentioned. So if you have any query, please stop me and ask the question that Satish, please clear, so I able to communicate with you. So when you ask me the question, either you use your microphone or may chat with me. So look at here the 10 to the power 0, this is the 1, and 10 to the power 1 means the 1, so left are the decimal point, and 10 to the power 2 is 100. So if you consider that point means 10.5, so this is the number, and this is the right decimal point, left decimal point and the right decimal point. So left decimal point is 2 to the power, and right decimal point is 0.1, 0.2, 0.01, 0.001, like that. So each digit appear to the left of the decimal point represent a value between 0 and 9. So the power of 10 represent by its position in the number. So the digit appear to the right of the decimal point represent a value between 0 and 9 times, so and increasing the negative power of 10. So 1 is the positive power, which is the left of the decimal point, and the right of the decimal point is the negative power. So 725194 is represented in expansion form. That how you represent it. You already know that this is the decimal point. So 5 into 10 to the power 0. So 5 into 10 to the power 0 means the 1. So only 5. Then 2 into 10 to the power 1, that is 20. 2 into 10 to the power 1 is 20. So 5 plus 20 is the 25. Then I say that the repetition 2 times is 100. So 7 into 10 to the power 2 is 700. So total is 725. Means I able to represent the left hand side, and for the right hand side it is the power means 1 by 10 to the power minus 1 by 10 to the power 1. 1 by 10 to the power 1, or 1 into 10 to the power minus 1. because it is a negative power. So if I divided 1 with 10, so it become 0.1. So for 0.9 representation, we have to divide it, this number, with 10, 1 divided by 9 into 10 to the power 2, or 9 into 10 to the power minus 2. So 9 into 10 to the power minus 2 is nothing but 0.09. So total, if I add this, it become 0.19. In similar way, I divided the 4 by 10 to the power minus 3. So the total number become 725.194. Now you use the binary number based system. It is one of the important question that which value I consider 0 and which value I consider 0.5. So 0 for logic 0, and we can use the logic 0 value either 0 or 0.7, 0.3, 0.2, because it is the logic 0 is considered as a voltage level. So if you design a system that the 5 volt, I say that 5 volt you consider as logic 0, and 10 volt you consider as logic 1. So it depends on you. But if you increase the voltage level, means it consumes the higher power. And if you consider the zero voltage, so how you know that it is active or not? 0 means nothing. So 0 voltage, maybe the wire is cut, so or some line is burned. So that's why we use some voltage to represent as 0. It is generally 0.2 or 0.3 volt, but there 0.2 or 0.3 or something is near to indicate that the line is okay, but the voltage level is 0. So the logic 0, and the higher voltage is 3.3. In some advanced system, the voltage level maybe is the lower value of 3.3, because if we able to operate a system in very low voltage, remember that if we able to operate a system in very low voltage, what happen? The low voltage consume less power. So less power, high voltage consume the high power, because you know that the power, or the formula of power, volt into ampere. So from this equation, it's clear that if I use the high voltage, then the power consumption is very high for the transaction between the 0 and 1. So when it's switching from one state to another state, so it is basically certainly change from 0 to 1. So when a high voltage fall into the low voltage, so if you sharply drop it, so it like that it's like a short circuit. So to avoid that type of power loss, we utilize a system for the low voltage. So the low power system, basically the low power VLSI system is implemented for that purpose, that the voltage level is between the logic 0 and logic 1 is kept minimum, so that it consume less power. So in case of the binary number system, which is used the base 2, which includes only the digit 0 and 1, the weighted value for each position, look at the weighted value of each position, it also indicated with the point. So if you go, this is the point here. So similar fashion which you utilize in decimal system, that is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4 and 2 to the power 5, like that, and this side is 2 to the power minus 1, 2 to the power minus 2. So 2 to the power 5 means 32. So this position value is 32, this position value is 16, this position value is 8, this position value is 4, this position value is 2, and this position value is 1. And look at this side is 1 by 2. 1 by 2 is 0.5, and 1 by 2 to the power minus 2, that is 1 by 2 to the power 2 is, that is 0.25. So this point is the basically the point value, and the right hand side they indicate that power of minus, and left hand side indicate the power of plus, that is the multiply of 2. So this is called the position. This is called the position, and this value is called positional weight. So positional weight means the value of that point. So if I say that what is the value positional weight of position 3, so the position 3 means we calculate the position from this point. So position 3 according to the left hand side, so it is 2 to the power 3 means the 8. So a number based conversion, that is binary to decimal conversion, multiply each digit by its weighted position. So clear? So multiply each digit by its weighted position and add each of the weighted value together, or use the expansion formatically. That look at the number, the binary number value is 1 1 0 0 1 0 1 0. So 1 1 0 0 1 0 1 0. So what is the position value of 1? So look at the this here, the point. So right side of this point, the number are not present, only the left side is present. So the LSB means the least significant bit. Least significant bit means which weight is lower. So this weight is lower because it is 2 to the power 0. So it is 2 to the power 0. Then 0, what is the position? Weight is 2 to the power 0, and here the digit is 0, means it is in off state. So 0 into 2 to the power 0. This point is 1 into 2 to the power 1. So this point value, digit value is 1, and the positional weight is 2 to the power 1. So it is 1 into 2 to the power 1. Then 1 into 2 to the power 0 into the power 2 for this, and this is 1 into 2 to the power 3. Again 0 into 2 to the power 4, 0 into 2 to the power 5, 1 into 2 to the power 6 and 1 into 2 to the power 7. So this value become 202. So this calculation, actually this is the method for calculation, conversion from binary value to a decimal value. But when you represent the decimal number, I write 202. So how you know that 202 is not 202? The 202 is the binary numbers of 11001010. So until and unless you convert this number into decimal number, you unable to determine that what is the equivalent decimal number. So this binary number is converted into the decimal number. But you get to the confusion that 11001010, that how it how I say that it is a binary value. It may be a decimal value, it may be a octal value, or it may be a hexadecimal value, or any other base conversion. So better to use a bracket. You use a bracket here, and in low it is write 2. So 11001010, use a bracket and you write 2. Then the representation is complete. So there are two methods that used to convert from integer number in decimal form to binary form. So two number. One is repeated division by 2. So if you repeated division by 2, then you divided the decimal number by 2 first. If the remainder is 0, on the right side write down 0. If the remainder is 1, then write down 1. So when you divided a number with 2, the remainder must be either 0 or 1. There are no other values for a number. So when you divided 0, when you divided by 2, the remainder either 0 and 1, and just write down the remainder 0 and 1 as per their appearance. So when you performing the division, the remainder which will present the binary equivalent of the decimal number are written beginning at the least significant digit, that is in the right, and each new digit is written to more significant digit to the left of the previous digit. So when you performing the division, the remainder which will represent the binary equivalent of the decimal number, you return the beginning and the least significant digit, and each new digit is written to the more significant digit in the left of the previous. So let's start. The number is 333. 333 is a decimal number, and we start the division by 2. So when we divided 2, the quotient is 166 and the remainder is 1. So the binary number I write here 1. So 333 divided by 2 is 166 and the remainder is 1, that is binary 1. 166 by 2, the quotient is 83, the remainder is 0 and the binary is 01. Then 83 by 2, This 83 by 2, the quotient is 41 and the remainder is 41. So the binary value is 101. Now for 41 by 2, look at this 41. This 41 is back here as a division. So 41 by 2. So 41 by 2 is 20. And what is the remainder? The remainder is 1. So this one is placed here. And the 20 by 2. The 20 by 2 is 10. The remainder is 0. And this 0 is written here. 10 by 2. The 10 by 2 is here. So 10 by 2 is 5. The remainder is 0. And this 0 is written here. Then 5 by 2. The remainder is 1. And this 1 is written here. And 2 by 2 is quotient is 1. And the remainder is 0. So 0 is here. Again, the value is 1 here. So 1 is appear here, 1 by 2. So is there any quotient? That not, but the remainder is 1. And this one is here. So it is 0, we have to stop here. So look at the policy. In the last case, you may neglect this point and you directly write here 0 and then 1. But when you implement into a software programming, then you write that the when the quotient either 1 or 0, we have to stop the division. So in this fashion we are able to complete a representation method from decimal to binary number system.